Hello friends, this video on electrochemistry part 1 is brought to you by examfear.com. No more fear from exam. The objective of this lesson is to describe an electrochemical cell and differentiate between galvanic and electrolytic cells. We'll see that we have something called galvanic cell and we have something called electrolytic cells. We'll find out a difference between them. We'll learn the Nernst equation and we'll try to apply the Nernst equation to find the EMF of a galvanic cell. We'll derive the relationship between the standard potential of the cell, the Gibbs free energy of the cell reaction, and its equilibrium constant. So there is a relationship between the standard potential, the Gibbs energy, and the equilibrium constant. So we'll try to derive that relationship for a cell. We'll define the terms called resistivity, conductivity, molar conductivity for an ionic solution. We'll try to differentiate between the electrolytic and electronic conductivity. Electronic conductivity is only for the metals and this ionic conductivity is for the electrolytes. We'll describe the method for measurement of conductivity of what? Electrolytic solution. So measuring the conductivity of a metal is easy, but measuring conductivity of electrolytic solution is a little difficult. And also we'll try to find their molar conductivity. We'll justify why there is a variation in the conductivity and the molar conductivity of the solution with change in concentration. There is a variation. The conductivity and the molar conductivity of a solution vary based on their concentration. So we'll see why they are varying and how they are varying. We'll also try to enunciate Kohlrausch law and we'll learn its application. We'll understand the aspects of electrolysis. We'll describe the construction of primary and secondary batteries and also fuel cells. And at last we'll explain corrosion, and we'll explain corrosion as electrochemical process. So those things we'll study in this chapter, right? We'll first understand galvanic cell and electrolytic cell. We'll use the Nernst equation. We'll find the relationship between the standard potential, Gibbs energy, and equilibrium constant. We'll define the term resistivity, conductivity, molar conductivity. We'll differentiate between ionic and electronic conductivity. We'll tell you how to measure conductivity of electrolytic solution, and we'll also find molar conductivity. We'll justify why the conductivities and the molar conductivity vary for electrolytic solution on change in their concentration. We'll also enunciate Kohlrausch law and understand electrolysis. Also we'll discuss the construction of primary and secondary cells and we'll explain corrosion. So the question is, what is electrochemistry? The whole chapter is about electrochemistry. So if you understand this term electro plus chemistry. Electro is what? Electricity, and chemistry is my chemistry. So any relationship between chemical and electricity or chemical reaction, I'll say. Right? So that relation is studied in electrochemistry. You must be thinking, right, there's a chemical, let's suppose sulfuric acid. How is that linked to electricity? But there is a link, and that link we'll try to understand in this chapter called electrochemistry. So the definition of electrochemistry is nothing but it is the study of production of electricity from energy released during spontaneous chemical reaction, and vice versa. That is nothing but use of electric energy to bring about non-spontaneous chemical reaction. Please understand this word, spontaneous and non-spontaneous. We have discussed this spontaneous and non-spontaneous in other chapters. I'll touch upon this in the next slide also. So what we are trying to say is, you have this chemical reaction. You have this chemical reaction, and that chemical reaction is spontaneous. That means it happens on its own and it releases free energy, right, to move to a lower state. So from this spontaneous chemical reaction, you are producing electricity. That is one aspect. For example, in this case, the example of galvanic cell. I'll tell you what is this galvanic cell. The next thing we do in electrochemistry is other way around. We take the electricity, for example, we use this electricity, and this electricity is used to drive non-spontaneous reaction. Why not non-spontaneous reaction? Why we are using non-spontaneous here? Why we are not using spontaneous? See, if this reaction, if a reaction is spontaneous, you don't need external source like electricity to make it happen, right? It will happen on its own. But some reactions are non-spontaneous, that means they don't happen on their own. For that, you need external source of energy. So here we supply external source of energy and the reaction happens. For example, hydrolysis of water. If you keep water as it won't hydrolyze. You need some external energy to hydrolyze water. So that's the non-spontaneous reaction. We'll talk about these things later. Let's understand the definition that electrochemistry is nothing but first is the production of electricity using spontaneous chemical reaction. The other is the reverse way. You have the electricity, use that electricity to perform a non-spontaneous reaction, right? And if you see, in all these cases, we deal with the redox reaction. And these redox reactions are generally separated and they are connected by electric circuit. We'll tell you why it is. Normally, redox reaction, any redox reaction, if you see, has transfer of electrons, right? Electrons transfer. So, if you somehow transfer the electrons via the circuit, you will generate current. And that's what they do, right? They perform redox reaction in different containers and somehow the electrons are transferred via the circuit and that produces electric current. That's the basis of electrochemistry. You will understand this when you will learn more about different kind of reactions. Just understand spontaneous and non-spontaneous reaction once again. I'll not go deep into this topic because we have discussed this in the last few chapters, but just the definition, spontaneous reaction is nothing but the reaction that release free energy. That release free energy. Correct? And it moved to a lower state, more thermodynamically stable state. So this process is one direction process. It moves in one direction without any external source of energy. Right? For example, if you see melting of ice. Melting of ice is one example of spontaneous. You just keep the ice, it will melt on its own. You don't need external source of energy for that. You have this salt and you dissolve in water. Salt, you dissolve in water. It will dissolve on its own. Rusting of iron, if you see in the normal STP, the iron will rust on its own. In fact, you must be curious. The diamond also converts into the normal carbon on its own, though it takes a long time, right? Also, smell, if you have some smell, it diffuses in the room. These are examples of spontaneous reaction. One thing I want to tell, in spontaneous reaction, it need not be instant, right? The word spontaneous is a little confusing. The word spontaneous says that it is instant, but it is not instant. For example, rusting of iron is not instant. Converting diamond to carbon is not instant, right? Though the smell diffusion is instant, but these two are not instant. So spontaneous only means that delta G is negative. That's all. Non-spontaneous just reverse. Delta G is positive. That means you have to provide extra source of energy to have this reaction happen, right? External energy source is required. And once the external energy source is required, the reaction stops, right? Reaction stops when external energy source stops. Correct? For example, hydrolysis of water. So if you pass current, water will hydrolyze. The moment you stop current, it won't happen. So these kind of reactions are non-spontaneous reaction where external source of energy is required and delta G is positive. Spontaneous reaction, delta G, this Gibbs free energy change, is negative and it releases energy on its own, right, without any external source. Burning of coal is also one example. Burning of petrol is also one example of spontaneous reaction. Now let's study the electrochemistry in our life. So here we'll try to explain why do we need electrochemistry in our life. What is the point of studying electrochemistry? So if you see all the electronic gadgets, almost all the electronic gadgets we see runs on battery, right? If you see the clock, the mobile phone, the camera, the inverters, laptop, torch, even the music players, the calculator, even the go-green, eco-green cars, right? These all runs on battery, correct? And if you see the word electronic, these are electronic gadgets, as I told. The electronic word came from the word electrons. And electron is a chemical word, right? Electron is something we read in chemistry, correct? So even if I'm talking about the electronic world, actually I'm talking about electron. And I'll show you how electron is the driving force. And this electron comes from chemical reaction. Chemical reaction. So electricity also word, if you see, electricity word also has electron, correct? Electricity also word has this electron. So it is electron which is responsible for electricity actually. An electron comes from chemical reaction, right? Electron comes from chemical reaction, that's chemistry. So there is a deep connection between the current and chemistry, and that is electrochemistry, right? So all the electronic device, if you see the electron word is there and they all come from electrons. I'll explain you why, right? They all come from electrons. But all these runs on batteries. All these run on batteries. See, there are different kind of batteries. And all these batteries run on chemical reaction. So in all these batteries, some chemical reaction happen. I'll explain you these kind of batteries, right? All this chemical reaction happen in this battery. But understand that in all these batteries, the chemical reaction happens. And it is this chemical reaction which gives electric current. Correct? So, as I told, the electron is the one which is responsible for all the current. And thus, electricity also had this word electron. Electronic also word has this electron. All these electrons that come out of chemical reactions, that is responsible for the current. The rusting of iron, if you see, the rusting of iron is a pretty big issue. Huge amount of money is wasted every year, right? A lot of accident also happen, the bridge collapse. But the good thing is, if you know this electrochemistry well, you can apply this electrochemistry to prevent this. You can prevent this rusting of iron. Correct? Electroplating, if you see, this is not gold actually, it may be some silver article or iron article also, but with the electroplating you get a good look and feel. Jewelries and other stuffs are made by electroplating. So electroplating also is nothing but a gift of electrochemistry. So it is in electrochemistry you study how to do electroplating. Correct? The green earth, if you see, if you know electrochemistry well, because the electrochemistry is what? Electrochemistry is nothing but chemical reaction which produces electricity. And we know that electricity is very much required for us. Even the video which you are watching now, you are watching because of electricity, right? So electricity is very much required. The fans, the tubes, the laptops, cameras, anything you talk about, the heaters, anything you talk about that needs electricity. It has become a very important part of our life. So if we know electrochemistry well, we can find efficient methods to produce electricity, right? Efficient methods to produce electricity. And with this, we can save Earth. Correct? Because the current methods, the earlier methods also, we have been improving day by day. The earlier method is not that great. It was not eco-friendly. But since if you understand this electrochemistry well, right, you become expert in this, you may develop new methods which are eco-friendly, which are good for Earth. Right? So it helps to create more eco-friendly technology. So if we talk about all this nervous system in the body, right, the whole nervous system, the transmission of all the sensory signals through the cells to the brains and vice versa, all this communication between the cells are known to have electrochemical energy. These are known to have some electrochemical origin actually. So these have some electrochemistry involved there, right? And a large number of metals, sodium hydroxide, fluorine, etc., hydrogen gas, chlorine gas, you can produce a large number of metals. So I'll write here, production of large number of elements, I can say, and lots of metals. Production and purification also. Production and purification. So using electrochemistry, we can do that. We'll explain you how to do this production and purification of large number of elements. So electrochemistry, if you see, has a huge importance in our life, right? The laptop, desktop, camera, everywhere we have electricity. Electricity, we need something to generate, normally battery, and everything runs on chemical reactions. So if it's just told the production of all these chemicals, we use electrochemistry. So if you see the whole cells is nothing but electrochemical cells or electrolytic cells. The cell is divided into two parts, either electrochemical cells or electrolytic cells. Electrochemical cells are the one which produce current, produce electricity. And they use electrolytic cells, they use electricity for non-spontaneous reaction, as I told. So here they use a spontaneous reaction to produce electricity. So as I told, electrochemistry, you do either of these. Either you use spontaneous reaction to produce electricity, or you use electricity to have a non-spontaneous reaction. So electrochemical cells are also called galvanic or voltaic cell in the honor of Voltas and Galvani. I'll explain you why they have such a critical importance in the electrochemical world. So it is just in the honor of the founder of electrochemical cells, the Galvani and Voltaic. Right? This is the look and feel of Galvani and voltaic cell. Anyway, we'll explain this in details in the next few slides. Before we understand the whole chapter, it's good to understand the history of electrochemistry. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.